Now we have a drain valve, right? The function of the drain valve is to drain the water from the system during the maintenance period, or when your system activates during case of the fire, we have to discharge the water completely. We have to make sure that the water is discharged completely from the wet pipe system, because if there is water inside the piping in some of the trap stations, what will happen? We discussed already that above the valve we have the air. So now those air react with the water, and we have the steel materials which cause corrosion. So we have to make sure that our design is designed in such a way that all the water there will be some drain connection, or there will be some slope connection. All the water discharges from the system after the detection of the fire, or the water goes inside the piping. So from here we can drain the water. We can drain water from this compressor. It will go there, and we have some auxiliary drain also, which is for dry pipe applications, right? Here we have a auxiliary drain. Right? We can see this is connected to the air lines. Right? And this is connected to the piping. We call it collect and drain. Auxiliary drain valve, collect and drain. So what is the idea of that? Now here we have we have air in these areas, or there might be some quantity of water inside that. So those water we need to discharge, but at the same time make sure we are not discharging air, because we don't have to discharge air. So what is the idea here? There is a two valve. One we have air here and one we have air. So we will open this one first, right? The first we will open this one, and we'll wait for this one. Once it's full, then we'll close this one, and then we'll discharge from there. We'll again open this one and close this one. Now this one will close and will open. So we just want to make sure we are only discharging the water, not the air, because if you are discharging the air, things will go out of control. It will take lots of time to come out of the system. Okay. Now we have a water gauge. This one will tell us the gauge pressure of water, right? The water pressure, how much pressure we are getting into the water side of the system. At the top we have another gauge which is for the air pressure, right? So this is giving us the air pressure inside the air side of the piping after the clappers. And again at the top of the mechanical accelerator, right, the quick opening device, remember we discussed in that the blackboard, we have also a air pressure gauge. So we have three gauges into dry pipe system. So one of the best way to identify even if it is a dry pipe, just look at the number of gauges, right? We have gauges, one for the air pressure, one for the discharge, one for the water pressure, for the air pressure, and for the air pressure at the accelerator. Now the red box here, you can see it is PS42 supervisory valve from the Potter, right? The manufacturer of the company from the Potter. It is UL listed, FM approved, and LPCB approved also, which is a requirement for the Europe and all those side. We have the CE marking at all. So this is PS42 supervisory switch. The function of that, it will give a signal to the fire alarm control panel for low and high pressure, right? So if the pressure into your dry pipe system goes below the set pressure, it will give some signal to the alarm panel that the pressure is low into the system. And if the pressure goes high also, it will give some input to the control panel that the pressure is high. So now what is the need of the pressure supervisor, right? Normally there are two concerns for the fire professional, space disadvantaged areas. That the first one, if the pressure goes below the setting, the pressure at the top time will be reduced, right? If the pressure will be reduced, the system will activate without a fire. So this water will go inside the piping, and right, so this will mix with the air inside the piping. Now, even though it is not getting out of the sprinkler, you have to remove all the waters from the system, because it's a dry pipe system, and if there is a presence of water into the piping, it will corrode easily, much faster than the normal process. This is the one concern. Now the other concern is that the high pressure setting, right? If your pressure is high into the air side, I explained in the beginning that we need something like 25 to 30 psi to hold the pressure up to 100 psi of water. So the air pressure should be around 25 to 30 psi to hold the water pressure of up to 100 psi. Or as for the recommendation of the manufacturer, right? So those settings should be done for the table provided by the manufacturer of the valve. In this case, we have a Tyco. So we'll get the data sheet of the Tyco for this valve and we'll see what is the air pressure required to hold this one and the clapper. So if the pressure goes higher than the recommended one, what will happen? There will be one problem in that. The water from the inside want to go open the clapper, but at the same time there are high pressure, it is not opening easily. So remember I said that we need to deliver water within 60 seconds. Now the water will not release within 60 seconds and it will cause the delay of water to reach to the remote area and extending the fire. And once the fire go beyond the design capability. What is the meaning of design capability? To design your sprinkler system for maybe 6 to 8 or 10 sprinklers to open at one time and you size your pump based on that. Now if the fire goes and water is not going to the sprinkler, the fire will continue to go into all the building. So maybe all the sprinkler will activate into those areas, causing divide of the flow and the pressure, and at that time water profile like the umbrella and all will not come in sufficiency and your fire will be out of control. So we have to make sure regarding the air pressure, the low and high, this is a requirement for that. Right? It is connected to the panel as I said. Now here we have a pressure gauge valve, the PRV. You can see it should be calibrated within 1 year. This PRV comes from the factory settings. It's normally set at 45 psi, right? So it is this setting is at 40 psi. So normally if the pressure inside the air side is maximum 40 psi, above 5 psi means at 45 psi this will open and release somewhere because we don't need pressure more than that. This is a factory set at 45 psi. If you can see, this is set pressure is at up to 33 psi, right? So it's based on the how much water pressure we are getting. Based on that, we need to set the settings, right? We can see the date of the calibration, right? 26 February. What is the next date? 25 February. So based on that, we have to calibrate it. Now, if you want to change the pressure setting, we can change by opening the jam nut and removing it clockwise or anti-clockwise to increase or decrease the setting of that. This is all about the air pressure system, right? So from this side, the air is going inside the chamber. Air is going inside the chambers and just holding the clapper so that it will not break. Now, how air is coming? The air is coming all the way from this line. You can see from this device. We call it air maintenance device, right? This one we call air maintenance device, right? So this is a regulator, and we have a different connection. Just 8 mm connection here and 8 mm orifice at this location and 8 mm orifice at this location. So now the function of the regulator is to regulate the pressure inside the fire protection system into dry pipe valve, and at the same time remove any kind of the dirt or any kind of the particles that is not good for the fire protection system. The air will normally come from this side and it will go from all the way this side to the system. Now we have an additional connection. This should be always in closed position, right? So if you want to, this one require maintenance by time to time. So while doing the maintenance for the air maintenance device, we have to close this one, right? Sorry, we have to open this one to push the system into the service, right? So for the temporary basis, we have to maintain this one and put the system into service from this side. Now this air supply is coming all the way, right? All the way from and this piping is connected to the compressor, right? So here we have the compressor for supplying air to our dry pipe system, and we have again pressure switch, right? It's a low pressure switch and high pressure switch inside that. So it will just open at the low pressure ratings and it will close at some high pressure rating, something like 40 psi or 45 psi as required for the dry pipe valves. So from all the way it will go from the stainer, if there is a stainer, right, it will remove any kind of the things from here, and from this time it will go to the dry pipe valves. Now this compressor, NFPA says that any compressor which is designed for dry pipe valve, right, should fill the piping within 30 minutes after the discharge, right? So when the system discharge, replace the sprinklers and then activate, put the system into the service. It should be full there within 30 minutes, right? So this is the function of the compressor. Now there is another backup, right? So suppose the compressor failed to restart, right? If compressor failed to restart and there is no pressure inside that one, we have a nitrogen cylinder, right, as a backup support. You can see we have a pressure around 1800 psi into that, right? We have a pressure around 1800 psi into this one. So this one will supply us the temporary backup support to our dry pipe valve. All the way this is connected to the same dry pipe valve system, right? So this is how the air system comes. This is one of the arrangement of compressors. Now some of the dry pipe valves coming with the riser mounted compressor, a small compact compressor mounted in the risers. Now it is the based on the requirement of the site, right? Suppose you are installing this one at your plant where we have the big compressor, instrument air compressor is supplying air to different utilities, not only to the fire but to the other valves also, right? So we can take directly connection from that one, and we don't need the riser mounted compressor because it might be a costly solution. Based on the requirement we can go to. But if you are installing this one just for one application in one riser, better to go with the riser mounted. Just regarding the costing of the project. Now we have again PS10 switch, right? The Potter PS10 switch, and the function of that one, if the system discharges water, right? If the water started flowing, it will detect the flow into the it will detect the flow, and from this supervised one, it will give a signal to the control panel that your fire protection system